gonna be limiting reactants. So limiting reactants means that if I'm going to do a reaction, I'm gonna have two things I'm gonna react, right? But one of them I'm not gonna have as much of the other, so it's gonna limit how much I can actually make. So instead of talking in chemistry sense, let's talk about something I know you know. Let's talk about making a sandwich, okay? So we're gonna make a sandwich, and we're gonna make a cheese sandwich. So kind of think like a grilled cheese. So I'm gonna have let me put this in, change my color. We're gonna have 4 pieces of bread, and we're gonna have 3 pieces of cheese. This is gonna be my reaction, okay? Now, I'm gonna tell you that to make your sandwich, we're gonna make it German style. In German style, our sandwiches are open face, which means we don't use 2 pieces of bread. So in here, it's gonna be a 1-to-1 stoichiometry. 1 piece of bread, 1 piece of cheese, okay? So if I told you that it's 1 piece of bread and 1 piece of cheese, how many sandwiches could you make? Well, you would say, well, Dr. C, that's easy, okay? I would make 3 sandwiches. Okay, so we'll make 3 sandwiches. All right, would you have anything left over? You'd have a piece of bread. Well, that kind of makes sense, right? But how did we figure it out? We said, okay, well, from the bread, I could have made 4 sandwiches. From the cheese, I could have only made 3. So whichever one was lower, that was how much I would actually make, okay? So we have names for all of this, okay? So this guy, these are my reactants. This guy limits how much I can make. So he is called my limiting reactant because he limits how much I can make. Okay? This guy I have extra of. I ended up having some extra left over. So he is called my excess reactant, or you might see reagent, either one. Okay. So the limiting reactant limits the amount of product and gets completely consumed. We didn't have any slices of cheese just left over. All of my slices of cheese went to product. Whereas my excess reactant, I'm gonna have some left over. So it's not completely consumed. Some will be left over. Okay? Now, this is what I was trying to make. So this is called my theoretical yield. This is how much I theoretically should make. All right, so those are my terms, my new terminology. So you might say, okay, well, why do we call it a theoretical yield? So the reason I call it a theoretical yield is theoretically, with 4 pieces of bread and 3 pieces of cheese, I should make 3 sandwiches. But in the real world, things don't always go as planned. I don't always make exactly how much I want. In my cheese example, everybody knows I have a dog named Guapo. So if I'm making a cheese sandwich, Guapo's gonna want a piece of cheese. So I'm theoretically not gonna make 3 sandwiches. I'm theoretically only gonna make 2 sandwiches because Guapo's gonna get a slice of cheese, okay? Or maybe you are kind of messy and you drop a slice of cheese or something like that, then you're not gonna actually make as much, okay? Sorry, I said theoretically. You theoretically still make 3, but actually you only made 2. Okay? Sorry about that. So things don't always go as planned. In the chemistry setting, you might spill things. When we do things in containers, sometimes things get stuck in a container and you don't get everything out. So think about if you're trying to eat something like peanut butter, you don't get every single piece of peanut butter out of that jar because things get stuck. So it's the same with us. Theoretically, I should be able to have everything in that peanut butter jar and use all of it, but actually I don't. So there's a difference between a theoretical yield, how much I should make, and an actual yield, which is how much I will actually make. All right, so let's write that down. So an actual yield is the amount of product that is made reaction. So this is how much you actually obtained. So in my example, I theoretically should have 3 sandwiches, but in my guapo scenario, I actually only get 2 sandwiches because I lost a piece of cheese, okay? So this is generally less than the theoretical yield. You're not going to say, oh, I can make 3 sandwiches, and then all of a sudden you somehow made 4 sandwiches. You don't just magically create things. The reason we say generally is because sometimes, say you have water or something can get into what you're making. So if I'm mixing 2 things, I know how much I should make. But what if something else gets added that wasn't planned? And so I have, my mass is gonna be a little bit higher than it should have been, and I think I made more product, but really it's because the product wasn't pure. It had some other stuff in it. So that's why we say generally. When we're talking about lecture and when we're doing our math, it's gonna be less, okay? So then we wanna say, well, how good were we at getting everything out? So if we go back to my peanut butter example, how much of the peanut butter did I get out of the jar? Did I use my finger and like get almost all of it out and get like a really high amount out of it? Or did I leave a lot left over? So if I want to know how much I actually obtained in relationship to how much I should have made, that would be my percent yield. So my percent yield tells me how much I actually obtained percentage-wise compared to how much I should have. And so this is my formula. Percent yield is the actual yield divided by the theoretical yield times 100. So actual divided by theoretical times 100. So this is going to be the efficiency of product recovery. How good was I in obtaining what I needed? So the efficiency of product recovery is generally given as your percent yield. And you're going to need to know this formula. So it's the actual yield divided by the theoretical yield times 100. And that's going to give me the percentage that I obtained. Did I get all of the peanut butter out of the jar, or did I only get like 80% of the peanut butter out of the jar? All right, so now we're going to transition from my peanut butter and my cheese sandwiches to chemistry examples. How do I figure out my theoretical yield and my percent yield if I'm actually just doing a chemistry reaction and reacting 2 things? So that's what we're going to talk about in the next lecture.